Hello my dear students. So I'm going to continue with the lesson. We started to discuss work, energy and power. So in the previous chapter we discussed what work is. So by applying a force, if you can move an object from its position or if you displace an object. Or else by applying a force, if you change the shape of an object. Then we say that there is work done on the object. Now the ability to do this work is what we call as energy. Even you all are familiar with that. When you are more energetic, you can actively do work. But if you are tired, if you don't have enough energy, you don't do work that actively. So you are familiar with that concept. Here we look at objects. When work is done, the ability to do work on an object or an ability to do work by the object is what we consider as energy. So energy. Energy is the ability to do work. You all have to remember these, students. Energy is the ability to do work. Now this energy also has the same unit as work. Why? Because when an object has the ability, that ability can be converted to work. So work has the unit joules. Energy also has the unit joules. So you all can remember the unit joules is given by capital J. The unit for measuring energy is the same unit joule that is used to measure the work done. So work done and energy both have the same SI unit joules. We need energy to do various tasks. So for any task, now I'm talking to you all listening to me, you can see this explanation. We do so many other work. So for all these, we need energy. We need energy to do various tasks. Even to move an object, crush an object, tear something, cut something, fix something. All these are work done, and to do that we need energy, and this energy is in different forms. So there are many different forms of energy. There are different forms of energy that helps us to do work. So like I told you all, now you all can hear me. When we say hear, you hear the sound. Now the sound is a form of energy. So that is one type, sound energy. Sound energy. Then you can see the board. If you see objects, to see objects you need what? You need light. Again, light is a form of energy. So sound energy, light energy. Then for cooking, doing many other things, we need or we use heat. Heat is also a form of energy. So sound energy, light energy, heat energy. And I'm sure you all are looking at this explanation through either your laptop or mobile phone. So to charge these, you need electricity. This electricity is also a form of energy. Electric energy. Electric energy. So these are different types of energy. Now in this lesson, students, we are actually looking at objects moving from one place to the other, or an object being lifted to a certain height. With these types of movement, there is the energy that is related, that is known as mechanical energy. So mechanical energy. In this lesson, we will be mainly focusing on mechanical energy. So this is what we are going to discuss here. And this mechanical energy is again of two types. One is known as kinetic energy. That is the energy possessed by a moving object. Kinetic energy. Then there is the potential energy. potential energy. Now this potential energy is either due to the position of the object or the shape of an object. Both of these forms, kinetic energy and potential energy, both together is known as mechanical energy. So like I told you all, in this lesson, we will focus on mechanical energy, under that kinetic energy and potential energy. So I'm sure you all can understand that clearly, students. With that introduction, I'll move on to the next slide. Kinetic energy. So when we say kinetic energy, the energy possessed by a moving object is known as kinetic energy. So the energy possessed by an object due to its motion is known as kinetic energy. So the energy possessed by an object due to its motion is known as kinetic energy. So always a moving object has kinetic energy. Now we will look at this example. As shown in figure, project an object A with a certain velocity along a horizontal flow so that it collides with a light trolley B. So look at the diagram, students. Pushing an object with a velocity. So we have a trolley and that is labeled as B. We have an object here that is labeled as A, and the object is being pushed in this direction with a certain velocity. So you are going to push with a velocity. You all know what velocity is. What is velocity? Rate of change of displacement. So we apply a certain velocity. Velocity is a vector quantity, so it has a magnitude as well as a direction. So you push it with a velocity. Now what will happen? Now this object is going to move with a velocity. It will come and collide with the trolley. And when it collides with the trolley, what will happen? The trolley will start to move. It will move to a certain distance and then it will stop. Since the object A came from this direction and gave the push in this direction, trolley will also move towards this direction. That is what you will observe. After the collision, the trolley would move some distance before coming to rest. So we push the object with a certain velocity. The object collides with the trolley. Because of the collision, the trolley moves. It moves to a certain distance and stops after a certain point. Next, project the object with a higher velocity. Now the trolley will move a longer distance before coming to rest. So what do? Initially we push the object with a certain velocity. The second instance, we increase the velocity. A similar thing happens. The object comes and collides with the trolley. Trolley moves, but now the trolley will move to a longer distance. So what is the difference there? We change the velocity of the object. When this velocity changes, the energy possessed by the object changes. Because of that, the way the impact is given to the trolley, that also changes. Now you all can remember, students, this has an energy. When the object collides with the trolley gets energy. Part of the energy possessed by the object is given to the trolley. So because of that, the trolley moves. Part of the energy possessed by the object due to its velocity is given to the trolley. so the trolley moves. Then you push it with a higher velocity. Then the energy of the object is higher and it gives more energy to the trolley, and because of that, the trolley moves to a longer distance. So that is the example given here. To understand this further, we will go to the lab and do this simple activity so that you all can get an idea about how energy is being transferred from one object to the other and how the trolley moves to different distances when we use different velocity for the object. Okay, students. So now we will try to understand the relationship between kinetic energy and the velocity of an object. So to do that activity, I have a trolley here. You're familiar with the trolleys that we use for activities, and I have an object, somewhat heavy object. So what I will do is I will roll the object with different velocity, and here as you can see, I have placed the trolley so that this part of the trolley comes in line with the 0 mark. So when I roll this object, this iron metal ball from here, when it comes and knocks the trolley, you will obviously know that the trolley will get pushed. It will move, and it will move to a certain distance and it will stop there. So there you can see if we change the velocity of the object, how this movement of the trolley changes. So to do that, you will need to observe how long the trolley moves when I push it with the object. So initially, I will roll the object slowly. I will roll it slowly. So here you can see it has come up to this point. Now if we consider this, it's the 26 centimeter mark. This is again, students, we are not going to do calculations, but for you all to get an understanding. So again, I will place the trolley here and I will move this faster. So here you can see the trolley moved to a longer distance. So if we really look at the distance, it's about 46.5 centimeters. So from that observation, students, you all can understand when I roll this object slowly, that is the velocity of the object is less, the kinetic energy of the object is less, and that kinetic energy, a part of that kinetic energy is transferred through the trolley. So when the object has less kinetic energy, less energy is transferred to the trolley, and that is why the trolley moved a short distance. When I roll the object with a higher velocity, then the kinetic energy of the object is higher and part of that energy is given to the trolley. Trolley moves to a longer distance. So from this observation, I'm sure you all can understand that when the velocity increases, the kinetic energy of an object increases. Okay, students. So did you all see the observation clearly? First, I use the metal ball. So when I push the metal ball with a less velocity, you saw the trolley move. It moved to a less distance and it stopped. Then I pushed it with a higher velocity. Then you were able to see that the trolley moves to a longer distance. So like I told you all before, what happens there? There is a less velocity there. Then the energy possessed by object A is less. When we increase the velocity, the energy possessed by object A increases. That is why the amount of energy given to B increases and trolley B moves to a longer distance. So from this observation, you all have to understand, students, that there is a relationship between the energy of the moving object depends on the velocity of the moving object. So what did we call this energy? We said it is kinetic energy. The energy possessed by an object due to its motion is what we call as kinetic energy. So that is kinetic energy. This is known as kinetic energy. And also, from the observation, from this activity, what did you all understand? When velocity of the moving object increases, the kinetic energy of the object increases. So that is very important. When the velocity of the moving object increases, the kinetic energy of the object increases. So that is why part of the energy of object A, that is that metal ball, that increased, and part of that was given to the trolley, and the trolley moves to a shorter distance when the velocity of the metal ball is less. But when I push it with a higher velocity, you were able to see that the trolley moves to a longer distance. Why? The metal ball has more energy. Because of that, it gives more energy to the trolley, and the trolley moves to a longer distance. You have to remember that, students. I'm sure you all can understand this concept clearly. So this is what we said. Kinetic energy, the energy possessed by an object due to its motion, is known as kinetic energy. Then we did this activity where we pushed the object A, that was a metal sphere, a metal ball, and because of that the trolley moved. And when we increase the velocity of the metal ball, that is object A, trolley moves to a longer distance. From that, we can conclude, or we can understand, that the kinetic energy depends on velocity of the object, and also when the velocity of the moving object increases, the kinetic energy of the moving object increases. I'm sure you all can understand that, students. So with that, we'll move on to the next slide. In this case, part of the kinetic energy of the moving object is transferred to the trolley, setting the trolley in motion. This is what I explained to you all before. When a higher initial velocity is given to the object, more energy is transferred to the trolley and it moves a longer distance. This is what we observe. This is what we observe during the activity. So you all can understand that. Similarly, push objects of various masses with the same velocity towards the trolley. So you can do this activity by using different objects. Instead of the metal ball, metal sphere, you can use some other object, lighter objects, heavy objects. So the mass of the object will vary. But we have to make sure that the velocity is the same. That is important. Same velocity. You will observe that the trolley would move further when knocked by a larger masses. So that is what you have to remember. Similarly, push objects of various masses with the same velocity towards the trolley. You will observe that the trolley would move further when knocked on by larger masses. As the mass of the object increases, the trolley moves further. That means the kinetic energy possessed by the large object or the object with higher mass is greater. So from those two observations, from the previous activity and this observation, what can you all understand? First I said the kinetic energy depends on the velocity of the object. Now we all can understand that the kinetic energy depends on the mass of the object. Now you all can imagine this also, students. Now say you are walking on the road. Normally accident shouldn't happen, but you all can think. If you are knocked by a bicycle, the impact will be less. The effect will be less because the bicycle has a certain mass. But with the same velocity, if it was a car, the mass of the car is higher. I'm sure you all can understand that the impact, the effect caused by that accident, if you are knocked down by a car, will be greater. Why is that? The velocities are the same, the mass is different. So when the mass is different, the kinetic energy possessed by the object is different. So when the kinetic energy is different, the impact given by the object is also greater. So that is why the trolley moves. So similarly, when the object has a higher velocity, the kinetic energy is higher. So two factors, the mass of the object, the velocity of the object. Both of them determine the kinetic energy of the moving object. From these results, it is clear that the kinetic energy depends on the two factors. What are the factors? Mass of object, mass of the object, and velocity of the object. You can simply write it as mass and velocity of the moving object. So two factors are those. Based on these two factors, we can derive an equation for kinetic energy. That is what I am going to do next. So then we'll move on to the next slide. The following equation, which involves the two factors, velocity and mass, is used to calculate the kinetic energy of a moving object. So to do that, we use the equation E kinetic. So E, the normal letter K is written as the subscript to indicate that it is the kinetic energy. E kinetic or kinetic energy is equal to half mv square. Here half is a value, the constant value that we use. M is the mass of the object and v squared is the velocity of the object and it is squared. So you have to multiply by velocity into velocity. Ek is equal to half mv square, or kinetic energy can be calculated using the equation half mv squared. And what is the unit? That is joules. You all can remember SI unit for work and energy, it is joules, capital J. That is the standard international unit. So in this equation, m is the mass of object, mass of the moving object. Then v is the velocity of the moving object, velocity of the moving object, and E subscript K is the kinetic energy of the object. Kinetic energy, or you can say just kinetic energy, or you can say kinetic energy of the moving object. Is that clear, students? You all have to remember this equation. This equation is very important. Kinetic energy is given by half mv square. Then, when the unit of mass is kilogram and the unit of velocity is meters per second, the unit of kinetic energy is joules. I have written that there also. You have to remember the mass has to be in kilograms and velocity should be in meters per second. Then you will get the unit as joules. So if we write the equation again, you have to remember E kinetic, that is kinetic energy, equals half mv square. So in this, half into m is going to be in kilograms into v squared meters per second into meters per second. So when you multiply everything together, you will get the unit kilogram meter squared second minus 2. But that is equal to the standard unit joules. This is the standard unit of energy, joules. So here you have to remember, students, it has to be in kilograms, that is mass of the object has to be in kilograms. And velocity should be meters per second. But since it is v squared, you need to multiply that twice. Meters per second into meters per second. This unit is equal to joules. Is that clear? That is the standard unit. Work is measured in joules. Energy is also measured in joules. So here under mechanical energy, we have discussed what kinetic energy is. I am sure you all can understand this concept. And kinetic energy depends on both mass and the velocity of the object. With that understanding, we will move on to the next slide. So we will discuss an example. The mass of an object is 6 kg. Calculate its kinetic energy when it is moving at a velocity of 4 meters per second. So you have an object. We can consider this as the object. This has a mass of 6 kg. And let's consider it's moving in this direction with a velocity of 4 meters per second. You are supposed to calculate the kinetic energy. So what is the equation? Kinetic energy. We use the equation as E kinetic. To describe its kinetic energy, we use the subscript K, and that is equal to half mv square. So in this, half into mass of the object is 6 kg. Now you all can remember the mass has to be in kilograms and the velocity should be in meters per second. 6 kg into 4 meters per second, but it should be v squared. So you have to multiply it twice into 4 meters per second. So then, if we calculate the value, you can see we can simplify this also. So here you will have 6 into 4 into 2. When you multiply kilogram into meters per second, we get the unit as joules. So that will be equal to 6 into 4 into 2, 6 into 4, 24 into 2, 48 joules. So when there is an object of mass 6 kg and if it is moving with a velocity 4 meters per second, the kinetic energy possessed by the object is 48 joules. And this is how we do the calculation. I am sure you all can understand that. With that, students, we'll move on to the next one. Example 2. Calculate the kinetic energy of an object of mass 4 kg at an instant that it is moving with a velocity of 2 meters per second. Again, I'm drawing these diagrams, students, then it is easy for you all to get the information. You can recall the process very easily when you study it with a diagram. So here again, the object is moving with a velocity of 2 meters per second. I'm using the same direction. Here they have anyway not mentioned the direction. We need to calculate the energy only. So the mass of the object is 4 kg. We need to calculate kinetic energy. E kinetic is equal to half mv square. So that is going to be half into mass is given to you as 4 kilogram and v squared 2 meters per second into 2 meters per second. So when we simplify, you can simplify, cancel off these two, 4 into 2 joules. That's going to be 8 joules. So when an object of mass 4 kilogram is moving with a velocity of 2 meters per second, the kinetic energy is 8 joules. I'm sure you all can understand this calculation. Anyway, this is given to you all in your textbook as a worked example also. So with that, we will move on to the next slide. This is an exercise given in your textbook. I'm sure you all would have answered this question now. If not, you all can try it by yourself first and then you can look at my discussion. So this is the question. You can look at the diagram. You can see a dog running. So it's related to the motion of the dog. The mass of a dog is 10 kilogram. If its kinetic energy is 20 joules at a certain instant, what would be the velocity it is running at? So the dog is moving. Let's say if we consider it as moving this way with a velocity of v, at that point the kinetic energy is given to you all as 20 joules. And they have said the mass of the dog is 10 kilogram. So you can calculate velocity. How do we do that? You all know the equation for kinetic energy. E kinetic is equal to half mv square. Now here we know the kinetic energy that is given to us, 20 joules. Then half, we know the mass of the dog also, that is 10 kilogram, but we don't know the velocity. V squared we don't know. So we can make the subject of the equation, v as the subject of the equation. So v squared is equal to 20 into 2 divided by 10. If you rearrange, this is what you will get. So from this, if you simplify, you get the value as 4. V squared is equal to 4. Now you can remember, students, when I showed you all the equation, mass is in kilograms and v squared, for each velocity we use the unit meters per second. That is why when you multiply them together, we get it as m squared second minus 2. So from this, what do we need to do? We need to find v. To find v, we need to get the square root of 4. That you all know is equal to 2. So 2 meters per second is the velocity of the dog. Square root of 4 is 2. So 2 meters per second. So here we have two values, the kinetic energy and the mass of the dog. We need to find the velocity. So what can we do? We can either substitute the value like I have done before. 20 joules equals half into 10 kilogram into v squared and then make v squared the subject, or else you can rearrange and substitute. Either way is fine. Whatever is more convenient to you all. So then you need to find velocity. When you simplify, v squared is equal to 4 and when you find the square root, you get the velocity as 2 meters per second. So I am sure, students, you also would have got the correct answer. Velocity with which the dog runs is 2 meters per second. With that, we will move on to the next question. Second one, the kinetic energy of an object of mass 500 grams is 9 joules when it is moving with a certain velocity. Calculate the velocity of the object at that instant. So here we have an object. and it is moving with a velocity, and the velocity is not given to us, it's v. That is what we need to calculate. We don't know this. Now the mass is given to us as 500 grams. Now can we use this unit? No. You all can remember when I discussed the equation, the mass has to be in kilograms and the velocity should be meters per second. So what should we do here? We need to convert grams to kilograms. Either you can do it here first, or else when you substitute, you can do the unit conversion. But this has to be in kilograms. That is very important. And the kinetic energy is given to us. E kinetic is 9 joules. So again, you all know we need to rearrange the equation. So here kinetic energy, E kinetic is equal to half mv squared. Now in the previous one, I substituted the values first and then made v as the subject of the equation. In this one, I will rearrange first and do the substitution. So here, v squared is equal to E kinetic into 2 divided by m. So there, kinetic energy 9 joules into 2 divided by mass 500 grams, but you need to divide that by 1000. So then of course, you will get it as this is going to be in kilograms. So 9 joules into 2 into 1000 divided by 500, that is going to be kilogram. So then we can simplify this. If we simplify, you will get it as, this also can be simplified. So 2 into 2, 4, 4 into 9, 36 joules divided by kilograms. We will get the unit as meter squared second minus 2. So to find the velocity, we need to get the root. Root of 36. So you will get this as 6 meters per second. 6 meters per second. Root of 36 is 6. 6 meters per second is the velocity of the object. Is that clear to you all students? Now at this point, you all have to understand this carefully. I have rearranged the equation first. So then I have substituted 9 joules into 2 divided by 500 mass. But since that is given in grams, you need to convert it to kilograms. So you have to divide by 1000. Now there are some students, some of you all might get confused with this. Then of course, you all can do it in a different way. Now let's say another method, you can first calculate the mass. 500 grams divided by 1000. So that is going to be 0.5 kilograms. That is easier. Some of you all find this more convenient. So do the unit conversion first and then you can substitute. And also like we did before, we can substitute it this way. E kinetic equals half mv squared. And there you all know the mass of the object is 0.5 kilogram and the kinetic energy was given as 9 joules. So then it is going to be 9 joules equals half and mass is 0.5 kilogram into V square. You can write it as 0.5. Some of you all prefer to write it as half a kilogram. That is also okay. This is equal to half a kilogram. Whatever is convenient for you all, you can use that value. So then if you rearrange, V squared is equal to 9 into 2 into 2. If 0.5 is half, so that also becomes 2. So then it's easier for you all. You can find the velocity, that is going to be root of 36. That is 6 meters per second. Is that clear to you all? The same method, students. Only thing, if you all can easily do the calculation with the equation itself, doing the unit conversion, you can use that method. Otherwise, you can do the unit conversion first and then you can rewrite it. Even here, now this I have written as 0.5 kilograms, but when you rearrange, I have written it as 2. To understand that, I will show it in a different color. Here we can also write it as half into, instead of 0.5, half into V squared. So when you rearrange, V squared becomes 9 into 2 into 2. Why? On this side we have half into half. So that is why you get it as 9 into 2 into 2. I'm sure you all are very familiar with maths. So you know all these rearrangements. You all can do it very easily. So this is the way to calculate the velocity of the moving object. So from this equation, students, E kinetic energy, that is EK, is equal to half mv squared. They will give you all two values and ask you to calculate the third quantity. Either the mass and velocity will be given and they will ask you to calculate the kinetic energy, or they can give you the mass and kinetic energy, ask you to calculate velocity, or else they can even ask you to calculate the mass of the object. They will give you the kinetic energy, they will give you the velocity and ask you to calculate the mass. That is also possible. Okay, students. So I'm sure you all have understood kinetic energy. What kinetic energy is? The energy possessed by an object due to its motion. And that depends on mass and velocity of the object. So using that, we came to this equation where we calculate kinetic energy using half mv squared. So in that, m has to be in kilograms and v has to be in meters per second. So that the energy will be in joules. So since you all are familiar with this calculation, I'm sure you all have understood this well. Now I'm going to move on to the second type of mechanical energy. When I explained energy, I told you all mechanical energy, there are two types. One is kinetic energy, the other one is potential energy. So now I'm going to move on to potential energy. Potential energy. Now when we say potential, even this you might have heard, potential to do work. So that again is related to potential energy. Now this potential energy of an object is due to its position or else due to the shape of the object. So that type of mechanical energy of an object due to its position or the shape of the object is known as potential energy. So if we define potential energy, the energy stored in an object due to its position or the shape is known as potential energy. Now when we say position, I'm sure you have experienced this before. You take an object, You lift it to a certain height and you drop it. When you drop it, that object will form an impression on the floor. Especially if it is a clayey floor or a sandy floor, you will get an impression there. The same object, if you lift it to a greater height and if you drop it down, then the impact will be more. Sometimes you would have experienced this by yourself. If something falls from a certain height and falls on you, maybe your shoulder or on your head, if it is from a short height, a slight distance, then you feel a certain impact. But if the object comes from a far distance, a higher level, the height is more, then the impact is more. So that is the potential energy due to the position of an object. We discussed this before also when we discussed work done. When you lift an object, I told you all, you are doing work against the gravitational acceleration. Now, when you do this work and you lift the object up, that work is actually converted to potential energy. So, the height increases, the work done increases, so the potential energy also will increase. So, that is the mechanical energy or the energy possessed by an object or stored in an object due to its position. Or we can say due to its height. Another one, due to the shape of an object. Now, you all might have played with these toys where you wind the toys. There is like a key, you rotate the key, you wind it. Some of you all might have even opened the car, you would have broken the car and you would have looked at that coil. There is a coil or a spring inside that toy car. So when you wind the car, what happens? The spring rotates and it actually tightens. When you release it, the car moves. And while the car moves, you all know the spring that became tighter loosens. So there is energy, that is potential energy, stored in the spring because of that shape. When you wind it, it curls, becomes tighter, and because of that, there is more energy stored. So that is potential energy. The same thing for an elastic. When you stretch an elastic, when you stretch a rubber band, you all have done this also. You take tiny pieces of paper, you put it to the rubber band like a catapult. You can pull the rubber band and let the small piece of paper to flow or move with a velocity. And the more you stretch the rubber band, the paper moves with a higher velocity. So when you stretch the rubber band, due to that stretching process, there is energy stored in that rubber band. That is the energy that is transferred to the paper, or if it is a catapult, to the stone. So that energy due to the shape of the object is also potential energy. Again, you might have seen when people do exercise, the string that they use, the spring that they use. So that when you stretch it, you have to do work, you have to pull it with a force, and there the spring stretches, and when that stretches, there is energy stored in it. And that energy is also potential energy. So the energy stored in an object, either due to its position or the shape, is what we call as potential energy. So from the examples I gave you all can understand there are different types of potential energy. So we'll be discussing two types of potential energy. One, when we do work against the gravity, that is lifting an object, due to the position, the potential energy is gained by the object, or potential energy is stored in the object, and that will be known as gravitational potential energy. And the rubber band, spring, anything that is elastic that can be stretched, when stretching, if there is potential energy stored in the object, we will refer to it as elastic potential energy. You all are familiar with elasticity. So, two types of potential energy, one because of the position, the other one because of the shape. So, we will discuss all those in the next few slides. Before that, so the energy stored in an object due to its position or the shape is known as potential energy. Then what will be the unit of potential energy? This is also going to be joules. J, joules. So whether it's work or energy, any form of energy. Earlier we discussed kinetic energy, now potential energy. The standard international unit, SI unit, is going to be joules. When we lift an object upwards by a certain distance, we perform work on the object. That is, we expend some energy to bring the object to its new position. That energy is stored in the object as potential energy. We will look at an example. Now say there is an object here. So let's say this object has a mass of 2 kilogram and that was lifted by a height of 1 meter. Now we have calculated this before also. What is the weight of the object? We calculated it as W equals mg. So mass is 2 kilograms. G is 10 meters per second squared. So that is going to be 20 Newton. So what is the force that is needed to lift the object? That is going to be 20 Newton. Force needed 20 Newton. So by applying a force of 20 Newton and lifting the object by a height of 1 meter, what do? We do work. So work done. Work done is what? You can remember force into height here. Force into displacement. Since here the displacement is against the gravity, lifting by a height, I have written it as force into height. So 20 Newton into 1 meter. That's going to be 20 joules. Now we have done this work. By doing this work, we have lifted the object. This work is stored as potential energy in this object. So when the object is here, it has a certain potential energy. But when it is lifted up, since we are doing work, it gains more potential energy. So when work is done, object gains potential energy. So here object gains potential energy. So when we do work and we lift an object from a certain position to a certain height, we do work and we do that work against the gravitational acceleration or against gravity, and that work is converted to potential energy. So here this is the change in position of the object. From below it goes to a higher height, and due to that position the object gains energy, or there is energy stored in the object. That is what we call as potential energy. Is that clear to you all students? So we lift an object by applying a force. When we do that, we are doing work, and the work is stored as potential energy in the object. That is the potential energy due to the position of the object. So with that understanding, we will move on to the next slide. So here also they have given a diagram. Like the example I showed you all, we will do another calculation here. Find the energy required to lift an object of mass 3 kg by a distance of 2 meters as shown in the figure given below. So there is an object, you can see 3 kg, but that has been converted to 30 newtons. Why is that? You all know weight is equal to mass into gravitational acceleration. So mass 3 kg, gravitational acceleration 10. So 3 into 10, 30 Newton. That is the weight of the object. So if this is the weight of the object, that is 30 Newton, you are going to lift the object against the gravity. So what should be the force applied? That is also same as weight. So you need to apply a force of 30 newtons. And what is the height? 2 meters. So when you lift the object by a distance of 2 meters, you will be doing work. And that work will be stored as potential energy. So again, we will do the calculation. Here you can see doing work against gravity. So here we will do the calculation. Now if we write mass of the object, is given to you as 3 kg. Then we need to calculate weight of the object. Weight of the object, you all can remember m into g. That is 3 kg into 10 meters per second squared. That is 30 Newton. So then, force applied to lift the object, that is also 30 Newton. So then height lifted. You can remember that was given to us as 2 meters. The object was lifted to a height of 2 meters. Then we calculate the work done. Work done. How did we calculate the work done? Force into height. So that is going to be 30 Newton into 2 meters. 60 joules. Newton meter, you can remember joules. Anyway, work done is joules. Now this work done is done against the gravity, and that is stored as potential energy. So here the work done against the gravity is stored as potential energy. So here potential energy equals work done to lift the object to a height of 2 meters. Therefore, potential energy equals 60 joules. So potential energy is equal to 60 joules. Now you can understand, students, from this work done, you can see if the mass of the object increases. Let's say instead of a 3 kilogram object, if you use a 5 kilogram object, what will happen? The force, the weight will increase. So the force that needs to be applied will increase. Because of that, the potential energy gained by the object will increase. At the same time, if you use the same object, but if you lift it to a higher height, instead of 2 meters, you lift it to 4 meters. Then what will happen? When you lift it to a greater height, you will have to do more work. So because of that, the work done will increase, and because of that, the potential energy stored in the object will also increase. So you can understand that the potential energy depends on the mass of the object, or in other words, the force of the object, force needed to be applied, and also the height to which we lift the object. Is that clear? So from that, we can derive an equation for potential energy. So now that you all have understood these, students, we will move on to the next slide. The same explanation is given to you, what I explained just now. Work done, mass of the object, gravitational acceleration into vertical distance lifted. So what is mass of object? M. What is gravitational acceleration? G. And vertical distance lifted is the height. So here H. So we can use these symbols. Mass into gravitational acceleration into height. That is the work done. So that is the work done, and that is what is going to be stored as potential energy. So from these, students, you will understand, you will see that the equation for potential energy to show it is potential is written as P. E potential is given by M into G into H. Why? Work done becomes the potential energy. Work done is calculated by multiplying mass into gravitational acceleration into vertical height h. So, potential energy is mgh. What is work done? Weight of the object into vertical distance lifted. So, that can be written in another way. Weight of the object is W into vertical distance lifted. That can be written as H. That is again work done. You can remember. Weight is force. Force into displacement or the distance moved by the object. So, weight into height, that is equal to distance moved by the object into the force applied. Then weight of the object is mass of the object into gravitational acceleration. This is the mass. This is gravitational acceleration. So, weight is equal to mass into gravitational acceleration. So, from that, in this equation, weight is weight into vertical distance lifted. In that, instead of W, if you substitute M into G, you get the first equation. So, from there, work done is equal to mass into gravitational acceleration into vertical height. So, from there, you can get this equation. From there, you can get this equation. You can get that equation. Potential energy, mass into gravitational acceleration into height. So, here, since the work done is 60 joules, the energy stored in the object at a height of 2 meters is 60 joules. That is, the potential energy of the object at a height of 2 meters is 60 joules. That is what I explained to you all. So, from all this explanation, we can get this equation. I am sure you all can understand that, students. So, with that understanding, we will move on to the next slide. Since work is done against gravitational attraction, This potential energy is known as gravitational potential energy. I explained that also before. We do work against the gravitational attraction, against gravity, gravitational pull. So because of that, we call the potential energy as gravitational potential energy. So when you lift an object by a certain height, there is work done, and the work done is converted to potential energy, and that potential energy, since the work is done against the gravity, we call it gravitational potential energy. In the above example, if we take m, that is the mass of the object, then we have g, gravitational acceleration, and h, height lifted. Then the equation that I told you all, potential energy, E potential is equal to mgh. Potential energy, mass into gravitational acceleration into height. Mass into gravitational acceleration, weight. Weight is force. Force into height is the work done, and the work done is potential energy. So either way, the work done against gravity to lift an object to a certain height is the gravitational potential energy. So we can give the equation for gravitational potential energy as E potential equals mgh. You have to remember this equation also. Then, the work done in lifting an object vertically upwards is stored in the object as potential energy. So, we have already discussed this. This energy is converted back into kinetic energy when the object is released. Let us do the following activity to show that the potential energy of an object is greater when its vertical position is higher. So, this is what happens, students. Now, we have an object here. We lift it to a certain height. So, from here to here, there is a height. There is the mass of the object. There is gravity, that is the weight. So, when you lift it to a height, there is potential energy stored. That is going to be mgh. And when this falls down again, you lift it to a height and you drop it, you release it, then that potential energy will be converted to kinetic energy. When the object is dropped, E potential becomes E kinetic. The potential energy becomes kinetic energy. So, the mgh, what you calculate as potential energy, will be converted to kinetic energy. You know the equation, half mv square. So, from that, you can do calculations. So, before going to that, like mentioned here, let us do the following activity to show that the potential energy of an object is greater when its vertical position is higher. So, from this equation, students, I told you all, now gravity does not change, but mass will change. I told you all about heavier objects, and also I explained about the height. To understand this, we will be doing activities. So, before I go to this activity, I will end this chapter here, and in the next chapter, we will start with the activities to understand about potential energy, how the mass of the object and the height to which the object is lifted affect the potential energy of the object.